Guys, we're getting started. Okay, indirect is kind of going about it in a roundabout way, not saying. So what we've been doing, all the proofs we've done up to this point is more direct. It's just, this is the given information, so this must be true, so this must be true, so this must be true. So, but an indirect proof is kind of proving it in a backwards sort of fashion. So here's what you do. On an indirect proof, you start by assuming like the opposite of what you're trying to prove. Okay? So you start by assuming, let's assume that that's not true, and then you argue until you get to a point of contradiction. So you say this, let's assume the opposite of what I'm trying to prove is true, and then you say, then this would happen, and then this would happen, but that contradicts what I know is true. Therefore, what I assumed must be false, and the original must be true. I know that sounds very vague. I don't know how to lay it out simpler in without an example. So let's try an example. So let's assume, I need to think of an example first. What are we trying to prove? Let's prove, trying to think of it. Who's got? We'll pick on Gracie. Let's assume. Let's try to prove. Let's say we're trying to prove Gracie is a good student. You like where this is going, Gracie? Gracie is a good student. That's what we're trying to prove. Okay. Well, okay, so we're trying to prove Gracie is a good student. So if I'm doing this indirectly, I'm going to assume the opposite of what I'm trying to prove. So what am I going to assume? Gracie is not a good student. So assume, I don't want to write all this out. Assume Gracie is a bad student. And then I'm going to argue until I get to a is a bad student. Then I'm going to argue until I get to a contradiction. So what do you think might contradict this? That Gracie's a bad student.
Good grades.
Is she has good grades. So I'm going to say something like, but Gracie has good grades. Suppose she could be cheating, but, I'm going to assume that's not true. So, but Gracie has good grades, therefore, which contradicts this, right? So therefore, this assumption is false, therefore this must be true. I don't want to write the whole thing. So you argue till you get to a contradiction. She has good grades, that contradicts my assumption. So therefore, Gracie is a good student, which is what I was trying to prove.
Wait.
Now, yeah.
I was going to say, can you go?
I didn't write the whole thing down because it takes too long, but that just kind of gives you an idea of how it works. You start by assuming the opposite of what you're trying to prove, and then you show that something's wrong with it. It's a contradiction to what you know is true.
Can you leave that on the word for a second?
And then so you say, therefore the assumption is false, and the original thing we're trying to prove must be true. Indirect proof. Clear as mud?
Absolutely.
Absolutely, exactly that clear. Okay. If it sounds scary, the assignment, it's a little bit scary, but the assignment itself isn't that bad. And I'll help you with the hard part. So, page 230.
If you can look there, you can see the lines up.
You can see the lines through paper, yeah. Have you ever seen like paper through a microscope?
Oh,
It looks like a bunch of ropes,
really?
like laying on top of each other, you know?
We should ask Miss Conrad to look at it.
Huh?
Science class. Yeah, she asked Miss Conrad.
Yeah.
Hey, Matt, and also try looking at it.
Yeah.
But look, guys,
Jackson.
we supposed to know what that
We
means?
got black.
It's wrong. It's not the fourth,
We're not
today is the fifth.
Is it?
Yes, yesterday was, wait,
Today is the
Never mind.
What?
Today's the fourth.
Computer.
Today's the fourth.
Computer disagrees with you.
Saturday is the sixth, and Sunday is the seventh.
no, listen.
Oh, wait.
Monday,
Wait, I think I know how to do this. If you don't mind.
Okay, so number one says, write the negation. It's been a while since we've done this. So basically, you just put a not in there. But if it makes more sense, you gotta make it like grammatically correct. So, we're not gonna say today is not Friday. Today is Friday.
But today's Thursday?
Oh, William.
No,
Wait, can I say?
just because it's not Friday doesn't
Can I
mean it's
say
Thursday.
wait?
But we're not saying
Someone.
a conclusion, we're saying the opposite. So we're saying it is Friday. Yeah.
So you could say for the last line, but today is the day that we go to church or something like that, right?
No, that was the answer. Today's Friday. We're just writing the negation.
Why is it?
Why are we writing the negation? Because to start an indirect proof, you have to start by assuming the opposite. Okay, so
The negation is the bottom thing. So like how we did Gracie is a good student, Gracie is a bad student, but Gracie has good grades. The negation.
the assumption that Gracie was a bad student was the negation.
Okay.
Like Gracie is not a good student. That was the negation. Yeah.
Number two be not all dogs.
No,
No, actually, the way you said it was better. If not all dogs bark, what's a better way of saying that?
All my
Some
dogs
dogs
don't bark.
Some dogs don't bark.
Oh.
Some dogs.
That's probably a better way. If you said not all dogs bark, that's completely acceptable.
Can I say all my dogs don't bark?
No,
Wait, what?
we're not talking about your dogs. We're talking about
But it
dogs.
says,
today is Friday.
oh, all dogs bark.
It's like a double negative.
So it's not all dogs. Anyway, number 3. The integer y is even. What's the negation of that? Integer y is odd. If it's not even, it has to be odd, right? If it's an integer. So the integer y is odd. It's probably the best way to say that.
We just put on.
How about 4?
No, write the whole sentence.
What do we say?
Okay.
What'd you say?
What's the opposite of greater than?
Less
It's actually
or equal to.
less than or equal to. Yeah. So did you guys hear that? The opposite of greater than is not less than. It's less than or equal to.
Isn't that the thing with the line there?
Yeah, with the line under it. Because if you guys are not greater than 16 years old, then you could be 16 or less, right? So it's less than or equal to. If you're not greater than 16, then you're less than or equal to 16.
So it's greater than, equal to, and less than.
No. The opposite of greater than is less than or equal to. Okay, number 5. Write the contrapositive. You guys remember the contrapositive? Probably not. This is how we represented a conditional statement. If A happens, then B will happen. You guys remember that? Like,
Yeah.
if the animal's a dog, it will go to heaven. Didn't I do that in this class?
Yes.
That's an example. The contrapositive, does anybody remember what it was? If not B, then not A. These two are logically equivalent statements. If the top one is true, the bottom one is true. That's weird. So it's like, huh? That was weird. Okay, anyways, this is contrapositive. So on number 5, if the car is out of gas, it will not start. So that's like our if A then B.
If the car starts, then it's not again.
Right, so you do the not on both of those. If the car starts, then it has gas, I guess. Yeah.
Like in B.
So we put in front, if the car starts, because that's the not B. Their B was, then the car won't start. So we're going to say if the car does start,
Then it has gas.
then it has gas. If the car starts, comma, then it has gas. Or you could say it's not empty or whatever. You don't have to say it exactly one way. The book actually put that it is not out of gas, but it's probably easier to say it has gas. What?
On A, did you put, less than or equal to?
Yeah, the opposite of greater than is less than or equal to. On both of them, yes. Oh, but you also switched the.
I know.
So on number 7, if angle 1 is congruent to angle 3, then triangle ABC is congruent to triangle DEF. So what would be the contrapositive? If what?
Triangle ABC is not equal to.
Right. It's not congruent. So guess what they put for not congruent?
Oh,
Congruent with a line through.
Yeah, congruent with the line through it. If triangle ABC is not congruent to triangle DEF, comma, then angle 1 is not congruent to angle 3.
But can you do number 6 with this, please?
It's like the.
Take me.
No, I'm not going to do 6 with you. You do, if not B, then not A. If not B, then not A.
Well, like the word, I think it's just the words that confuse me.
If you have a not, if he is not envious,
So
that
wait.
means he is envious.
Then if he is envious, then he is not.
He does not demonstrate.
Then
Yeah.
he's not. Okay.
I have all my notes in that chapter.
You should have a notebook. for
Thumbs
that.
up.
I should have.
Okay, kind of forgot where I was at. Number 9.
Yeah.
Write the initial assumption for the indirect proof of each statement. So it's like if we were going to prove this indirectly, what would we start by saying? We're going to start by assuming the opposite of what we're trying to prove. So number 9 says if a car has anti-lock brakes, then that's like the given statement, and then what we would try to prove, it will not make skid marks on the pavement.
There's a car and there's pavement.
Yeah.
It doesn't those.
Okay, well, no. So if I was trying to prove that indirectly, I would start by assuming the opposite of what they said was true. So I would start by assuming the car this car makes skid marks on the pavement. So let's see, that was number 9. Assume the car made skid marks.
Is that the answer?
Yes, on the pavement. We are not actually going to prove it. We're just like starting a proof. Starting by assuming the opposite.
Can you up on 10?
How would you just say the line N is not held?
Yeah, that's right. Number 11. If y equals 27, then 3y equals 81. So what are we going to assume? 3y is not equal to 81. So assume on number 11, 3y is not equal to 81.
Wait, Mr. Jordan, is that the answer to number 9 that you just put up there?
Yeah.
Okay, thank you. I was confused.
What's the answer?
Well, pay attention. The reason you don't know what the answer is because you're doing the evens instead of listening.
He only will. He only. Yes. Ooh.
When you say on the second part that it's listed as ridiculous,
Which one?
well,
12. Yeah, the opposite of greater than is less than or equal to.
would you put both or just the last one?
Just the last part.
Assume 3y is not equal to 24.
the first part is like the given part, it's the last part is like the proved part. So you gotta assume the last part, opposite of the last part. Number 13, which two statements are a contradiction? Line P said lines J and K intersect. Lines J and K are coplanar. Or lines J and K are parallel.
P and R.
Yeah, can lines intersect and be parallel? No. So P and R would be the answer. Those are contradictory statements. They can't both be true at the same time.
Oh, so just
On an indirect proof, you got to argue until you reach a contradiction, and then you say, therefore my assumption was false, therefore what we were trying to prove is true. That's how it works. I'll let you guys figure it out. 15. Angle C is acute. Measure of angle C is not equal to 90. And angle C is obtuse, which P and R are contradictory statements.
For what number?
15.
Oh, I get it.
Okay, 17 is pretty similar. It says, state whether each pair of statements is contradictory or not. If it is not contradictory, you gotta say why it's not. Okay, on 17, God's word is truth, God's word is fallible. Is that a contradiction? God's word is truth, God's word is
Yeah.
fallible. Yes, so just put contradiction.
Mr. Jordan.
Yeah.
What was 11 and 15?
What are you doing when I'm talking? Are you just trying to do the evens too?
No, I did a few of them, but then I
Yeah, you did a few of them. There you go. Okay, number 19. Triangle. XYZ. This is kind of a trick question. I don't like this one, but we'll do it anyway. Triangle XYZ is equilateral. Triangle XYZ is isosceles. Is that a contradiction?
No.
Okay.
No, because
It doesn't appear to be. Well, actually, okay. You should say You should think it. You should probably think it is a contradiction, but it's not. Yeah.
because an equilateral has two equal sides.
Kind of. You're kind of on the right track. Yes. An isosceles has two equal sides. That doesn't mean it can't have three equal sides.
I knew.
So it's kind of a trick question.
Okay, not to.
It's not a contradiction because an isosceles can have three equal sides. The definition of an isosceles is it has two equal sides. That doesn't mean it doesn't have three equal sides, though. It's kind of a trick in the definition. Yeah, I wish they would have. They probably should have defined it as having exactly two equal sides, but they didn't. So I don't like that question. It's not. It's because the definition is not good enough.
So all equilateral
All equal.
equilateral triangles are isosceles triangles, but not all isosceles triangles are equilaterals.
Are not necessarily equilateral. Yeah, that's true. Okay, number 21. Write the modus ponens or modus tollens. Oh my goodness. What is modus ponens and modus tollens?
Is it and?
Okay, basically, this guy right here is modus ponens. What does that mean? It means if I say something like, if the animal's a dog, it will go to heaven. Bert is a dog, therefore Bert goes to heaven. I just used...
Why would you name a dog that?
Why would you not name a dog that? That's
You're
a
right.
better question. I just use modus ponens logic. But if I say, Bert did not go to heaven,
Bert's not.
then Bert is not a dog, that's modus tollens.
Where does it
You have that way back in chapter 2.
You can give her like extra credit to do all these. Look at all. She works hard.
She gets her own extra credit by getting all the answers right when she has her notes. Okay, number 21. Venn diagram. You guys remember what a Venn diagram was? Those circle pictures on 21. Okay, what does it mean if the dog circle is inside the mammal circle?
Dogs are mammals.
All dogs are mammals. If the animal's a dog, it's a mammal. We're supposed to say that also. So these are basically, I have 2 sentences. The first sentence is, if the animal's a dog, then it is a mammal. I'll write this down.
Sparky's outside the circle.
If,
If it's a dog, it's a mammal.
yeah, if the animal is a dog, then it is a mammal. And then guess what we're going to say about Sparky?
If it's a mammal, then it's not Sparky.
Sparky, what can we say about Sparky? Sparky is not a mammal, therefore,
He's not a.
whoops. You guys remember the therefore symbol? I think I wrote it like once. But it's easier than writing the word therefore, so I'm going to do it. Therefore, Sparky is not a dog.
Where's Sparky?
Sparky is an iguana.
How do you think that's sad?
I'm making stuff up. The story of my life.
He can be a goose.
No. Sparky is an iguana.
What is it about?
Iguana, goose.
Therefore, it means therefore.
Oh.
Yeah, crap.
Yeah.
It didn't seem like
It's just easier than writing the word therefore, so and the book did it, so I decided to. Okay, 23. What does it mean for the integer circle to be in the rational number circle? What'd you say? If n, yeah, that would be okay, but I'm just going to say all integers are rational numbers, or if it's a rational number, then it's an integer. We'll say that. If it's, or if a number is rational, that would probably be a better way of saying it. I'll go that route, I guess. You don't have to say it the exact same way. If a number is rational, then, oh, I said it backwards. If a number is an integer, you guys remember what integers and rationals were?
Yes, I have it in my thing. Integers are on the number line, and rationals are like negative third.
Rationals are things that can be written as fractions.
3.3 repeating.
There, finally.
How do you draw an iguana?
It's just a large lizard.
How do you draw a lizard?
Long tail.
Scaly.
That was a good one.
Sure, more or less, wait for
Look at iguana.
Huh?
I think this is like an iguana.
Yeah, I mean,
Wait,
roughly.
Nice
You can say it later. Save it for lunch. You said it looks like a squirrel.
It's like a beaver.
You see him open up like a little sack.
I can forget. What can we say? Okay, what can we say about -3 on this one? -3 is what?
Is an integer.
Is an integer, so it's rational. Integer, I'll use the therefore again. Therefore, it is rational.
I think that's what
No, they won't. 24 is a lot like what? Marianne, 24 is a lot like what?
I'm out of lead.
21, yeah.
The size piece just slides up inside. It's too
Yep. Yeah. It's possible to be greater.
I'm just gonna hope it's just.
It's possible, but how is it possible?
I believe.
Well, I mean, if it wasn't,
It's like it's just
There-
sitting
there-
there.
there- there is
If
no
it was
doubt in
equal,
my
it would be
mind.
true. Okay. 27. Okay. This one's challenging, but I'm gonna help you. So this would be hard to do on your end. So we're trying to prove. So the given is the square of an integer n squared is odd. So you don't really have to write this part, but the given is basically n squared is odd. And what we're trying to prove basically is that n is odd. Did you guys know that an odd times an odd is always odd? You ever thought about that?
Don't.
Like, I don't know, 9 times 7 or whatever, 63. Odd times odd is an odd. Always happens. So how are we going to prove it?
are we doing a root?
Assume, okay, this is like where the problem, this is basically what the problem gave us. This is where I'm going to start with my answer. What am I going to assume, do you think? Assume n is even. Assume the opposite of what we're trying to prove.
Do we need to write this whole thing?
Yes. This is not a statement reason. This is not a statement reason proof. It's going to be more like a paragraph of me talking. Assume n is even. Okay.
So do you do the contradiction or whatever now?
I'm gonna. Well.
Oh wait, that is.
I'm gonna. No. You start with assuming the opposite of what you're trying to prove. Argue until you reach a contradiction. And you say, therefore, the assumption is false, and what we're trying to prove must be true. That makes sense? So I'm trying to prove that this is false, basically. I'm gonna argue till I run into something that says this is false. And then, therefore, this is true. Okay. This is kind of weird. I know you guys haven't seen anything quite like this before. Do you guys know what is special about even numbers?
They are even.
Yeah, what makes
that
it?
up to even?
What makes an even number even?
It can be divided by 2.
Yes, that's a good definition. All evens are multiples of 2. Like 2 times something equals that. But Will said they're divisible by 2. That's the same thing. So I'm going to say n equals 2k, where k is an integer.
Is that it?
Is that it? No. We have not.
I'm working on one more line, Mr. Jordan.
Then you're in trouble because we got like 3 more lines or something.
No. What?
Okay, we have not reached a contradiction yet. All I've said is n equals 2k. Does this make sense? If n is an even number, then it's 2 times something else. Like think of any even number.
Does that say
20. 20 is 2 times 10, right? Or 100. 100 is 2 times 50. N is some even number, 2 times something. Okay. Then n squared would equal 2k squared. Does that make sense? Are you guys tracking with me so far?
Why can't we abbreviate ourselves even okay?
Are most of the other ones a little more simple than this? Or a little simple?
Probably not, but I didn't assign one.
Even or an odd number.
Logs don't have links.
You have to
guys know how to simplify that? What's 2k squared?
4K. No.
4k
4K.
squared.
Now divide by 2.
Okay, here's the problem. 4k squared is divisible by 2, right? Which means n squared, which means 4k squared is even, which means n squared is even. Which is a contradiction because we start off by saying n squared is odd.
Well, that's not.
It makes sense.
Okay, so our assumption is false, that n is even, and n must be odd. I know it's kind of weird. It is weird. It's just kind of...
Then 2K.
You guys probably use indirect thinking without thinking about it.
I have a question.
But when you put it in a math problem, it just confuses
Where did
people.
we get 2K? I forget.
2k, I just made it up. I said n would have to equal 2k, where k is an integer, because that's like what an even number is.
So
Leave
that
it.
could be 13K. Or
Is that
No,
it?
2, because all even numbers are divisible by 2, or are multiples of 2. If n is even, then 2 times something would equal n.
okay, then where K is an integer, then
Are we done?
that and 2K.
N squared would be this squared,
I got
and this squared is still even. So therefore,
Wait, so why is it still squared though? Didn't you square it
No.
above? Like how did you get to the stage of multiplying 2K by 2K?
because up top we knew that n squared had to be odd, and if I square this, I'm showing it's not an odd. Okay, so let's just keep going here. We can't spend
That's
too
it,
much
it's
on
not?
it. No, all that stuff I said, I have to actually write it,
Yeah.
but I need to say it
That's.
succinctly here.
Less than or equal to, so, but if it's true, then it could be less than.
Huh?
Is this the last part?
I'll use the therefore symbol again. Therefore,
This can help. I can't even see because of your head shot.
n must be odd.
Thank you.
I actually probably.
This is too much.
Wait, shouldn't it be that n should be even? I thought we were trying to prove that n is odd.
We're trying to prove that n being even makes a contradiction. Therefore,
He owned you once again.
I just forgot about that one.
Are we done with this?
Yep.
We turn around, he's like red.
yeah, we're done.
He's like got some.
On 18.
Why don't I show up to school tomorrow, you guys?
Yeah, it's not a contradiction because they could be.
Do it on first